Okay, the next one from 11th standard, motion and the motion and the straight line chapter, equations of motion. So you know very well, already so many times we discussed the equations of motion, but in the form of normal equation, and then the second thing by using the graph method we discussed. Okay, but this is different one. Okay, so by using the calculus method, then how to derive the equations of motion. Okay, listen. See that. So in this calculus method, so now let's consider that the acceleration of the body is constant. Okay. So now, so you know already. Now I can remember that b is equal to u plus at, s equal to ut plus half at square, and v square equal to u square plus 2as. But you know this special name. So actually this is the relationship between velocity and time. Okay, it's a relationship between the velocity and time. Okay, and then the second one, generally it's velocity. Okay, velocity. So simply write velocity and time relation. And then this one, second equation, you know, that is s equal to ut plus half a square. That is the position and time relation. Okay. And the third one, v square equal to u square plus 2as. That is, you know, position and velocity relation. Okay, it's a special name. So now let's derive one by one. So first I take v is equal to u plus dt. How to derive? Okay. Basically, so it is one of the good practice. Then how to use the integration. Okay. So please listen. The velocity time relation. So velocity time relation, you know, that is a v is equal to u plus u. So this only we are going to derive. Okay. Listen. So just you observe that acceleration of the body at any instant is given by the first derivative velocity with respect to time. First derivative velocity. Okay, so velocity already is there. So first derivation. So first derivation means we have to differentiate. Okay, so differentiate means what? That is velocity, change in velocity with respect to the time. Change in time. So change in velocity divided by change in time. So that only I wrote here. Okay. So change in velocity divided by change in time. Change in velocity divided by change in time. So it's nothing but acceleration. Okay. So first derivative, because we derivated one time only. Okay. So acceleration is equal to dv by dt. Okay. So now, therefore, the dv is equal to acceleration into dt. Okay. Right. So the taking integration on both sides of this equation. So you know the integration symbol. So it's the integration symbol. Okay. So suppose, for example, integration means one round is given. So I want to calculate the total length of the round. Okay, that is the circumference of the circle. Okay, for example. So no need to calculate the entire round. Okay. Suppose just I know the limit from here to here. Okay. From here to here, some limit I know. Okay, so this distance I know. Or otherwise, from here to here distance I know. Okay. So here will be one time, remaining 2 time, up to here 3 time, up to here 4 time. The integration of this one, how many times? 4 times. Up 1 time, 2 time, 3 time, 4 time. Okay, so it is integration. Okay, so we have to calculate the total value. Okay, so the taking integration on both sides. Okay, so the left side, you know, that is a change in velocity. So change in velocity is integrate. So velocity integrate from where to where? For example, let us take one bike and something, car something. Okay, so here, okay, this is the car. Now car, it's initial velocity u. Then now I am actually changing velocity. So initial velocity changed as now initial velocity u is changed as the final velocity v. So changing velocity what? That is dv. So changing velocity changing from v to u to v. Like that, starting velocity u, final velocity v. So here the starting time is 0, the final time is taken as t. So the right side, acceleration is constant, so remaining changing value of time. So time will changing from 0 to t. Okay? Right. So now how to integrate? Now we apply the symbol alone now. So the integrate formula, listen, because it is a first time derivative, after that integral dx is equal to x, that is the formula. Integral dx is equal to x. Okay? So here the integral dv I can write as p. Integral dx equal to x. Like that, integral dv is equal to p. So that only I wrote here. That is a p. Then after that, upper limit and lower limit. So that is the procedure. Upper limit and lower limit. It will be limit. Okay? From where to where. That is a limit. So upper limit, then lower limit. The next step, upper limit minus lower limit. Upper limit value we have to apply here. Apply limit value. Then minus again lower limit value. That is v minus u. Okay? Then is equal to acceleration is constant already you know. So constant we can't do anything. Okay. Then the remaining is what? Integral dt. So again integral dt how to write? T. Okay, that is t. Again upper limit, lower limit. Upper limit what? T. Lower limit what? 0. Therefore v minus u is equal to a into upper limit minus lower limit. That is t minus 0. Therefore v minus u is equal to a into t at. That's all. So remaining is 0 now. Therefore v minus u is equal to at. Therefore v is equal to u plus at. Okay, that's all. So very simple. Now you know. So first time derivative, the velocity first time derivative, that is acceleration. That is acceleration is equal to with respect to time. That is very important. Velocity changes with respect to time. That is acceleration. Because there is a rate of change of velocity is nothing but acceleration. That is the origin. Okay, so there is a beginning point. Then one more important step, that integral of dx is equal to x. So that is the formula. Okay, so now we derive the first equation, v is equal to u plus at. So it is wrong. So the next one, s equal to ut plus half at square, or otherwise we can say that is a position and time relation. See that, that is the second one, the position and time relation. So you know that is s is equal to ut plus half at square. Okay, so this whole expression only we are going to derive. Okay, listen, so if you observe that here s equal to ut plus half at square, okay, so now it is a relationship between that the position and time relation. Okay, so the change in position with respect to time. So let's take that time here. So by the definitions of velocity, so that only I say the change in position with respect to the time. That is dx divided by dt. So change in position divided by change in time. So change in position means that is dx, change in time means that is dt. So that is velocity. Okay, or otherwise in this question we use letter s, that is the position. Okay, so instead of x I will change as s. So I can write v is equal to ds divided by dt. So both are the same. Okay, right. So we need s value only. So let's say ds is equal to v into dt. So that is the next step. ds is equal to v into dt. Okay. Therefore ds is equal to, okay. So we know already from the equations once you remember v is equal to u plus at. Okay. So you know that v is equal to u plus at. So this value, instead of this v value, we can substitute v is equal to u plus at here. Instead of this v, we can write u plus at here. Okay. Now the dt value multiple inside. Okay. So u into dt plus at into dt. Okay. Now as usual, let's take integration on both sides. Okay. So now we are going to apply the calculation method. Okay. So the taking integration on both sides. Okay. So you know that this is integral s, this integral u into dt, integral at into dt. So that is a step. Then as well we want to write the what is that limit. We apply the limit. So as usual, the car starting from one position. Okay, it reaches some other position. Here initial velocity u, the final velocity v. Okay, and then let's take the starting time is 0, ending time is t. Starting position is 0, and ending position is s. Okay. Okay. So like that, first one with respect to the position. So starting position is 0. After sometimes the position is s. So 0 to s. Like that, the next step, that is initial velocity. I mean initial velocity is some velocity u, that is fixed one. Okay, some velocity, initially some velocity. So that's with u. Next a is the acceleration. Okay, so listen, u into dt, this dt, sorry, u into dt. So u into dt, here changing value only the time factor. So starting time is 0, ending time is t. Okay, like that, the next one, a t into dt. You know a already is constant, so let's take that a is outside. So here a is, let's take outside, and the remaining changing time value. Time value as usual, starting time is 0, ending time is t. Okay, that's all. As usual, upper limit minus 1, because integral ds I can write yes. Then upper limit minus lower limit. Upper limit what? Yes. Lower limit is 0. So s minus 0 is what? Yes. Like that, the next one, u is already outside. The remaining integral dt is there. Integral dt is what? T. Then again upper limit, lower limit. Upper limit minus lower limit, I can write t minus 0. Okay. So write one more steps here are, so u into t minus 0. Okay. Upper limit minus lower limit. So 0 no need to write, remaining one ut only. So write ut. Okay. Right. And then the next one. Here acceleration is constant, the remaining integral t into dt. Here one more formula I am going to include. So you know in the previous derivation, that is integral dx is equal to x, like that we derive. Okay. Now here integral x into dx, that format, integral x into dx. So now what is the formula? That is integral formula. So integral x into dx formula, let us imagine here x power 1 is the thing is there, that means 1, that is 1. So x power 1. So its formula is x power n plus 1 divided by n plus 1, that is the formula. Okay. அப்ப இந்த இடத்துல என்ன சொல்றேன் அப்படின்னா இந்த integral வந்து x, integral x power n into dx. So it is a formula. Okay. Okay. இப்ப suppose இந்த இடத்துல x squared means x squared into dx means what will come? X power 2 plus 1 divided by 2 plus 1. That means what? X cube divided by 3 will come. Okay, like that, this is the common formula. Integral x power n into dx plus x power n plus 1 divided by n plus 1. Okay, so now in the n position என்ன இருக்கு? Just 1. அப்ப என்ன வரும்? t power 1 plus 1 divided by 1 plus 1. That means what? T squared divided by 2. Okay. So now I can write acceleration as usual. Here t power 1 into dt. If you integrate பண்ண என்ன கிடைக்கும்? T squared divided by 2. That's all. By using this formula. So this formula is very important. Frequently we are going to use. Therefore s equal to ut plus half at squared. I rearrange just half at squared. Okay. So now you know the relationship between the position and the time. That is s equal to ut plus half at square is derived. Okay. Okay, next one. B squared equal to u squared plus 2as. So you know this is position and velocity relation. See the derivation, position and velocity relation. Okay. So now if you observe this equation, b squared equal to u squared plus 2as. Okay. So position and velocity relation. Okay. So that velocity changing with respect to time. So let's take that idea. So that will lay out. So acceleration of the body at any instant of the time is given by the first order derivative with respect to the time. Okay, so which is first order derivative means that is it is what is that, velocity. Okay, so velocity with respect to time. So we can get that is acceleration. Okay, so acceleration is equal to change in velocity with respect to the time. Okay, so acceleration, okay, in this equation acceleration is okay, then velocity also okay, but time factor will not come, one thing. Then one more thing, that displacement, I mean the position is needed. So if you observe in this equation there is no position, so we want to introduce the position, so multiply and divide by ds, so the value will not change. Okay, so multiply and divide by ds, then after that interchange interchange, that the ds will come here and the dt will move there, so we can write dv divided by ds into ds divided by dt. Okay, so ds divided by dt means what? That is, that is changing position with respect to the time. So changing position with respect to time, that is, velocity. Okay, so now this term we can write as velocity. Therefore, acceleration is equal to dv divided by ds into v. Okay, then the next one, ds. Okay, because generally v square equal to u square plus 2as. So let's we take velocity term alone right side or left side. Okay, so now let's take the velocity term right side. Okay, so ds is equal to dv divided by a into t. Okay, right. So now I can write, so d is moving here, then acceleration is coming here, therefore ds is equal to dv divided by a into v. Okay, but anyhow, there is a 1 by a, that means a is the acceleration is constant. Okay, we are no need to integrate. Okay, so therefore, so let us imagine the velocity term only is the right side. Okay, so the integration on both sides. Okay, so the integral ds equal to 1 by a, because integration not come for acceleration, so 1 by a, then integral v into dv. Okay, because the velocity is changed, then position is changed, but constant acceleration, because that is the question already we mentioned, the constant acceleration. So now I can write that the change in position from 0 to, yes, some position change, and the velocity changing from initial to the some final, so u to v. Okay, right. Therefore, that integral ds we can write s, then upper limit minus lower limit, that is s minus 0, so s will come already so is equal to then 1 by a. Then this is already I mentioned the formula. There is integral x into dx, that is integral x power n into dx. How we can write? X power n plus 1 divided by n plus 1. So it's a formula. Okay, so like that here integral x power 1 is there. So what will come? X power 1 plus 1, that is 2, that is v squared divided by 2. Okay, then again upper limit, then lower limit, upper limit minus lower limit. So 1 divided by 2 is a number, let's take outside, so 2a. By remaining v square, upper limit v, lower limit. So upper limit minus lower limit. So v square minus u square. Okay, now this 2a is coming here, so 2a into s is equal to, the remaining is what? V square minus u square. So we need, we rearrange as per our convenience. Anyhow, we got the equation from here itself, we got the equation. So according to our basic idea, v square equal to u square plus 2as. Therefore, rearrange this equation, v square is equal to, v square மட்டும் இங்கே வச்சுக்கிங்க, minus u square moving in that side, so plus u square, so u square plus 2as. Okay, so okay students, so now you know the relationship between the position and the velocity also. Okay, I hope you understand. Okay, so already we discussed equations of motion, what is the basic method over, and then by using the graphical method also over, and then third one by using the calculus method. By using the calculus method only, what is it? It is a derivation for the higher level. Okay, for 11th standard level, by using calculus method is essential. Okay, thank you.